Okay, today we're going to talk about compound probability, which is the same thing as the probability of multiple events. So in the past, we've talked about just a single event. Now we're going to talk about having two or more events happen. But before we go there, we need to clarify some things, and that is that events have two possibilities. That one is that they can be independent events, that is, that they do not influence the probability of each other. An example would be rolling a dice, flipping a coin, or the events could be dependent. In that case, they do influence the probability of one another happening. An example would be choosing a marble from a bag and not replacing it, taking a card out of the deck and not replacing it. Those events would be dependent. So let's look at some examples and decide. Okay, on your paper you have them written out, so think about what they are and then you can listen. Roll a number cube and then spin a spinner. Hopefully you realize those events are independent. You could pick one flashcard and then another from a stack of cards. Those are going to be dependent because now you have one less card from the original stack. You select a coin from your pocket, replace the coin, and then select another coin. Okay, I can still pick the same coin. Those events are independent. So, when we have independent, or excuse me, when you're talking about compound probability and finding the probability of two or more events, then you are going to multiply the probability of each event together to calculate that probability. So let's do some examples. First off, you have two dice. What is the probability of rolling a 2 on the first one and a 5 on the second one? So we're going to multiply the probability of getting a 2 times the probability of getting a 5. So the probability of getting a 2 on a die, you have 6 sides. One side has a 2, so it's 1/6. Probability of getting a 5, again, you have 6 sides to it. One of them has a 5 on it, so it's 1/6. We multiply them together and we get our answer of 1/36. Another example, or some more. What's the probability of rolling a 6 on one die and an even number on another die? So we're looking for the probability of a 6 and an even number. The probability of a 6, it has 6 sides. One of those sides is a 6. And an even number, that would be 2, 4, 6. So there's 3 even numbers out of a total of 6 sides. So you can simplify. If you do it by hand, put it in your calculator, your calculator will give you back 1/12. Always need to simplify your probabilities. Okay, another example. What is the probability of flipping a coin and landing on heads 3 times in a row? So if I flip a coin, it has two sides, one of which is heads. So the probability of getting a head is 1/2. And then if I want another head, it's 1/2. And I want another head, it's 1/2. So the probability of landing heads 3 times in a row is 1/8. Okay? Those are independent events that we just did. Now look at what happens when we have dependent events. You have a bag with 3 red and 6 blue gumballs. You're going to find the probability of getting red, then a blue without replacing it. So these are two events. So the probability of getting a red is you have 3 red balls out of a total of 9 balls. So the probability of getting a red is going to be 3 out of 9. Then you do not replace it. So we do have 6 blue gum balls, but we do not have 9 balls anymore because we took one out without replacing it. So it will be 6 out of 8. Put it in your calculator, simplify, multiply by hand, you'll get an answer of 1/4. So the probability is 1/4. Okay, look at another one. Same 3 red, 6 blue gum balls. What's the probability of getting a red and then a red again without replacing the first? So again, the probability of red is going to be 3/9. But what's going to change this time, if I want to get a red the second time when you do this, you assume that the first one was red, so that means I don't have 3 red balls anymore. I only have 2 red balls. out of the 8 because I didn't replace it. So that's why we multiply by 2 over 8. And again, put it in your calculator. You will simplify it and get an answer of 1/12. Okay? And just a few more. You have a bag with 5 yellow, 2 green, 4 pink gumballs. What's the probability if you don't replace the first one? So we're never replacing. All right. So probability of pink then yellow. I have 4 pink balls out of a total of 4 plus 2 is 6 plus 5 is 11. So 4 out of 11. And then a yellow one, I have 5, but again, I'm not replacing. So the 11 now becomes a 10, so it's 5 out of 10. And when we multiply that, we will end up with 2 out of 11. Okay, I have a bag of coins, 5 pennies, 5 nickels, 5 dimes. What is the probability if you don't replace the first one to get a nickel and then a dime? So how many nickels do I have? I have 5 nickels out of a total of 15 coins. So that's 5 out of 15. And then a dime, I have 5 dimes, but I didn't replace it, so it's going to be 5 over 14. And that is going to give me 5 over 42. Okay, last example. You have a bag of coins. There are 5 pennies, 5 nickels, 5 dimes again. What's the probability if we don't replace the first one? And this time we're going to go for a nickel and then a nickel. So we know that a nickel is 5 out of 15. And then we have another nickel. So we're still going to have 14 on the bottom, but we're not going to have 5 because we already picked a nickel. So we only have 4 out of 14. And when you multiply across, you're going to get 2 out of 21. Okay, so you have a worksheet now. Keep in mind that the beginning of this worksheet, okay, is reviewing a little bit of the type of probability that you already did. The problems start with or, which means that it's a single event. And then at the bottom is where you pick up with what we've done today in this video. So at the bottom of this, or when you do your worksheet, remember, write the word or so that I'll know there's a difference between the and of what we've been doing and the or of what you've been doing previously. Let me know if you have any questions. Thanks.